Okay, so let's talk about the atom. The fundamental building block of, well, everything. For the longest time, nobody really knew what it looked like on the inside. It was a total mystery. That is, until one man stumbled upon an incredible secret right at its very heart. This is the story of Ernest Rutherford.
And, calling him that? It is absolutely not an exaggeration. In an age filled with brilliant theorists, Rutherford was the guy who loved to get his hands dirty. He wasn't content to just think about how the world worked. He wanted to physically take it apart, piece by piece, and see for himself. And that hands-on approach, it changed science forever.
So, how did you do it? How did this one man change everything? Well, our story starts about as far from the center of the scientific world as you can possibly get, and it follows a journey right into the very heart of the atom itself.
Yeah, see, the guy who would literally redefine matter didn't come from some long line of European scientific royalty. Nope. He was a farmer's son from way out in rural New Zealand. And get this, he was one of 12 kids. He was armed with a super sharp mind and just a massive sense of curiosity.
And that sharp mind took him places, really fast. I mean, look at this timeline. In less than 2 decades, he rockets from a college in New Zealand to a super prestigious fellowship at Cambridge, then gets a leading professorship in Canada, before finally taking the chair of physics at Manchester. His journey to the top was quick, but his journey into the atom was just getting started.
All right, so let's dive into the science that first made him famous. At the turn of the 20th century, the hottest new mystery in physics was radioactivity, and Rutherford, he was about to become its absolute master.
So other scientists knew that elements like uranium were giving off some kind of strange energy. But Rutherford was the one who said, okay, let's not just look at it, let's trap it and test it. And as soon as he started running experiments on these invisible rays, he quickly realized, hang on, this isn't just one thing. There are several different types here.
He was the first person to actually categorize them. He basically created the alphabet for radiation. He named them alpha, beta, and gamma, all based on their power to punch through matter. Alpha rays were the lightweights, stopped by a piece of paper. Beta rays were tougher, and gamma rays? Whoa, those were the heavyweights, the most powerful of all. This simple classification became the bedrock for the whole new science of radioactivity.
His next huge discovery showed that this radioactive decay wasn't random at all. It was precise, like clockwork. He's the one who coined the term half-life to describe that constant, predictable time it takes for half of a radioactive sample to break down, a concept that's now fundamental to everything from carbon dating ancient artifacts to running nuclear reactors. So, for this amazing work, for discovering that elements could naturally transform into other elements, he was awarded the Nobel Prize in 1908. But here's the twist. It was the Nobel Prize in chemistry. Rutherford, who was a physicist through and through, loved to joke that it was the fastest transformation he'd ever witnessed, watching himself turn from a physicist into a chemist.
But believe it or not, the Nobel Prize wasn't even for his greatest discovery. The one that truly made him a legend was still to come. And it all centered on a ridiculously thin sheet of gold foil, some tiny alpha particles, and a result that would change science forever. This was the million-dollar question back then. Scientists knew atoms existed, sure, but what was their internal structure? How were all the little parts arranged? What did one actually look like?
The best guess at the time was something called the plum pudding model. The idea was that an atom was this diffuse, kind of soft ball of positive charge with a little negative electrons just dotted throughout it, like plums in a pudding. It seemed logical enough, but no one had ever really put it to a serious test. So to test it, Rutherford had his assistants shoot a beam of positively charged alpha particles at that super thin gold foil. If the atom was a soft pudding, those particles should just sail straight through. But that is not what happened. I mean, most of them did pass through, but some were deflected at really big angles. And a tiny, tiny fraction, about 1 in 8,000, bounced straight back. These are Rutherford's own words describing his shock. Just think about that for a second. Firing a cannonball at a piece of tissue paper and having it ricochet back and hit you. It was completely impossible according to the theory of the day. It meant the entire model of the atom was just flat out wrong.
Rutherford realized there was only one possible explanation. The atom's positive charge and all its mass weren't spread out at all. They had to be concentrated in an unbelievably small, dense point right in the middle. An alpha particle only bounced back if it scored a direct head-on hit with this tiny core. He had discovered the atomic nucleus. And in doing so, he revealed that the atom is mostly empty space.
Now, discovering the nucleus wasn't the end of the story. It was the beginning of a whole new one. A huge question popped up immediately. If this tiny core actually existed, what was it made of? So he went back to his favorite method, shooting particles at stuff. This time he fired alpha particles into nitrogen gas, and he noticed that the collisions were literally knocking a new, smaller particle out of the nitrogen atoms. After a lot of careful measurement, he realized he was looking at the nucleus of a single hydrogen atom.
He had done it. He had split the atom, and in the process, he'd found a fundamental building block of every single atomic nucleus. In 1920, he gave this new positively charged particle its name, the proton.
But you know, solving one puzzle just creates another one. If the nucleus is jam-packed with positive protons, basic physics says they should repel each other and the whole thing should fly apart. Rutherford predicted there had to be another particle in there, one with mass but no electrical charge, acting like a kind of nuclear glue. He even called it the neutron. And sure enough, his own associate, James Chadwick, would go on to discover it years later, proving him right.
You see, Rutherford's discoveries didn't just win him prizes. They laid the entire foundation for the next 100 years of physics, creating a legacy that goes way beyond his own direct work.
His impact as a mentor was just as profound. I mean, his laboratory was like a production line for physics giants. You've got James Chadwick, who found the neutron we just talked about, Cockcroft and Walton, who were the first to split the atom with a machine, Otto Hahn, the father of nuclear fission, and even the great Niels Bohr, the guy who created the modern model of the atom. It was a hall of fame, and they all called Rutherford the boss. When he died, he was given one of his country's highest honors. He was buried in Westminster Abbey, taking his rightful place in the pantheon of the greatest scientific minds in history, right alongside Isaac Newton and Charles Darwin. A pretty fitting tribute for the farm boy from New Zealand.
But maybe the ultimate tribute is his permanent place in the very language of science itself. Element 104 on the periodic table is called Rutherfordium. His legacy is forever etched into the fabric of the universe he helped us understand.
So, we'll end with this question. Nuclear energy, modern electronics, huge chunks of our understanding of chemistry and the cosmos, so much of it traces right back to that one moment of shock and curiosity in a dark lab in Manchester. It just goes to show how one person's refusal to accept the expected answer can change absolutely everything.